In this video, we want to talk about how we can determine when functions are increasing and when they're decreasing. And there's a few different ways to think about this. One of the ways to think about an increasing versus a decreasing function is kind of looking at the function graphically. So we're going to start there, then I'll give you the formal definition, and then we'll do kind of an example. So if we're thinking about the graph, let's say that I have a, let's say I have a downward pointing parabola. And I'm gonna grab a different color pen here. Okay, so here is a downward pointing parabola. And when we think about functions increasing versus decreasing, we are reading the graph as we move from left to right along the x-axis, similar to how we would read a book, right, from left to right. So when I start at this left-hand side of my downward pointing parabola, I can see that I'm going to, as I move along the graph, the y values are rising, right? So because as I move from left to right on the x-axis, at least up until we hit the vertex, right? Up until we hit the vertex, my y values are rising. So this side of the function, the left-hand side, is increasing. Once I get to that vertex, which by the way, at the vertex, the function is neither increasing nor decreasing. And we'll talk about that a little bit more later on. And then if I'm at the vertex and I think about then moving to the right along the x-axis and following the graph, I can see there my y values are going down, right? The further right I go, the more down and down and down they go. This is the decreasing side of the graph. Okay, so that's one way to think of it. Just as I move from left to right along the x-axis and follow the graph, are my y values going up or are they going down? If they're going up, that part of the function is increasing. If they're going down, that part of the function is decreasing. The other way to think about this graphically is we can actually think about the tangent line. We've talked about tangent lines in previous videos. If I'm looking at this left-hand side of the function that we already have labeled increasing, if I look at any point along this side, I can see that those tangent lines at those points, the slope of those tangent lines is positive. And that will be true on any increasing part of the graph. The slope of the line tangent will be positive. Similarly, if I look at this decreasing side, all of these tangent lines will have a negative slope. And that tells me that the function there is decreasing. So we can simply read along the function from left to right to see if it's increasing or decreasing. We could also draw this kind of imaginary tangent line and say, okay, what would the slope of this tangent line be? If it's positive, that's an increasing function. If it's a negative, that's a decreasing function. You'll notice, interestingly, at the vertex here, where it's neither increasing nor decreasing, the tangent line there would be horizontal, right? And a horizontal line, its slope is zero. It is neither increasing nor decreasing. Therefore, at that point, because we have a zero slope of the tangent line, it is neither increasing nor decreasing. Okay. So this is one way to think about where are functions increasing and where are they decreasing, is by looking at them graphically. Another way to think about increasing and decreasing functions is to actually look at the definition. And the definition of increasing and decreasing functions formally looks like this. So this is our formal definition. It says, suppose a function f has a derivative at each point in an open interval. Then if f prime of x is greater than 0, sorry, there we go. I just accidentally switched pages here. If f prime of x is greater than 0 for each x in the interval, then f is increasing on the interval. Okay. If f prime of x is less than 0, so if f prime of x is less than 0 for each x in the interval, then f is decreasing on the interval. So same wording in both of these descriptions. It's just the sign of the inequality is the opposite, and one says increasing and one says decreasing. So that's why I haven't repeated the language on these two lines. I left kind of some dots in there. But if f prime of x is less than 0 for each x in the interval, then f is decreasing on the interval. And if f prime of x equals 0 for each x in the interval, then we know that f is constant on the interval. Okay, so this is essentially just saying formally the same thing that we said when we looked at the graph. Because remember that these f prime of x's, when we see those, that's talking about the slope of the tangent line. So if the slope of the tangent line is greater than 0, or if it's positive for each x in the interval, then f is increasing. That's what we saw right here. Slopes of the tangent line were positive, f was increasing. Similarly, if f prime of x, the slope of the tangent line, is negative for each x on the interval, then f is decreasing on that interval. So again, here we are decreasing on our graph of our downward pointing parabola. On the right-hand side, the slope of these tangent lines was negative, so that's the decreasing part. In this particular function that we were looking at in the graph, the downward pointing parabola, the only constant part that we have is just at the vertex, right? We don't actually have an entire interval where the function is constant. The slope of the tangent line is only actually a constant at just that one point for a downward pointing parabola. Okay, So this sort of starts to give us an idea of, if we didn't have a nice graph, if we just had an equation and I wanted to determine where is my function increasing and where is my function decreasing and where is it constant. If we just had an equation of that function, we can still find those intervals without graphing. And we're actually going to be looking at that over the next few videos. In the next video, we're going to talk about critical numbers, and then we'll start putting all of these concepts together to give us the increasing and decreasing test.